Okay, so we're going to be looking at a special factoring pattern called the sum of two cubes. This is when I have some example where I have some number that's cubed plus some number that's cubed, and it always factors into this pattern right here. So here we have an example of 8x cubed plus 27. The thing about 8x cubed I recognize is that this is a perfect cube. What I mean by that is this. If I have some number and it's been raised to the third power, whatever it outputs to me is going to be a perfect cube, so long as I use whole numbers. So if I put in, for example, 4x into this problem, when I distribute this exponent, this is going to become 4 to the third power times x to the third power. And so if I go ahead and multiply 16 times 4, I get 64x to the third. This is considered a perfect cube because 64x to the third can be rewritten as some variables raised to the third power. So 8x cubed is a perfect cube because I can raise it, some number raised to the third power is equal to 8x cubed. So if we keep our exponent algebra in mind, I can't just write 8x here, because if I distribute this exponent, the 3 will also go to the 8, so it'll become 8 to the third, which is not what we have here. So what to the third power gets me 8x cubed? Well, it's going to be 2x, because if I distribute the 3 into 2x, I get 2 cubed x cubed, which is 8x cubed. So that's going to work out in my answer. So I can rewrite it like this: 2x raised to the third power plus what number raised to the third power is equal to 27. And so if we take the third root of 27, we get 3. So that means if I'm looking at this expression, a to the third plus b to the third, that means a is equal to 2x and b is equal to 3. So these are my a and my b, and now I'm just going to plug in a in for every single a that I see, and I'm going to plug in b for every single b that I see. And then this is going to help me factor this expression. So let's go ahead and let's do that. So 8x to the third plus 27, that can be rewritten as a plus b times a squared minus ab plus b squared. But I'm not going to write that out. I'm just going to plug in a and b now. So it's a plus b, which a is 2x, plus b, which is just 3. And then I can plug in a squared, remember parentheses, so it's 2x squared minus ab, which is going to be a 2x, times b, 3, plus b squared, which is just 3 squared. And now I can go ahead and do a little bit of algebra in my second set of parentheses. So I get 2x plus 3 times, distribute the 2, so this is going to become 2 squared x squared minus 2x times 3, which is just 6x, plus 3 squared, which is 9. And now I can just simplify this last little bit here. And so I get 2x plus 3 times 2 squared is 4, x squared is just x squared, minus 6x plus 9. And now this would be the factored example of this original polynomial x cubed plus 27. So we can say x cubed plus 27 can be rewritten as 2x plus 3 times 4x squared minus 6x plus 9. If you'd like to see another example that's similar to this, I'm going to be doing a video on the difference of two cubes, which I will put on the screen right now. So feel free to go check that out. It's very similar, but it's different rather than sum. So it's going to be dealing with two cubes that are being subtracted. Otherwise, thanks for watching. Feel free to subscribe if you want to see more of these videos, and I hope it helps.